Hello, and thank you everyone for joining us on today's webinar brought to you by Distilogix. Today we're very excited to have Big Switch Networks, who do SDN, and Compuverde, who do SDS, come online with us to explain their technologies around a very exciting space of software-defined technologies. As you all know, Distilogix has a big focus on these areas, and software-defined, and the whole software becoming the focus as opposed to the hardware and the data center. Is becoming more and more of a trend these days, and we're hearing a lot about a lot of buzzwords around software-defined technologies. We've done a lot of searches on on these types of technologies, and we feel like these two companies do provide some of the best technologies around software-defined networking and storage. So from Big Switch, I have with me Mr. Ollie Sheridan, and from Compuverde we have Mrs. Sindhusha Marakani, Ms. Sindhusha Marakani, and they will be presenting their respective technologies. We do have a few more people trickling in, so we'll probably give it another few minutes, and then we will start the presentation. All right, so we'll make a start now. So we'll start with Compuverde's software-defined technology. Sindhusha, are you there?
Yep, I'm here, Omar.
Okay. So the floor is yours, Sindhusha.
Thank you, Omar, so much for the introduction, and welcome everyone to today's webinar. So to begin, we will start talking a little bit about Compuverde and also software-defined storage and what it means. So for us, when we say software-defined storage, it basically means complete freedom for you as a consumer to choose how you want your storage to be designed. So you could choose between a completely simple bare metal setup where you're directly installing on hardware, or you could also choose to have a virtualized environment, which we call the hyperconverged. Then you also have the choice to choose between different kinds of storage. So you're making your solution future-proof by having a file system, an object store, and the block storage in one package. So this is really interesting because as your business has three different verticals, which is the communication interface, your logic, and storage. Traditionally, as we know, all of them were stacked one above other, and they were scaling vertically. But as we see today, the other two, which is the communication interface and the business logic, kind of scale horizontally, while the storage is still stuck with a vertical scale. So this is what we aim to change. So we also want your storage to scale horizontally along with the other components you have in your business. And that is where Compuverde comes in with our scale-out storage solutions. So it is a really interesting time to look into software-defined, as Gartner says that by 2019, more than 50% of the storage installations that are out there in the market will move towards a software-defined kind of setup, moving away from the traditional storage. So before we look into what different features you get from Compuverde, dig deeper into the technical parts, I would just like to talk about being in the market with a lot of different software-defined vendors out there. Why is it interesting to look at Compuverde specifically? Oh, I'm really sorry. There seems to be a small issue where I missed a couple of screens. So I hope you see my screen now, Chris?
We do.
Yeah, perfect. Yeah. So let me back it out one slide where I was showing you a graph about how Gartner promises or how Gartner predicts that by 2022, there will be a major shift in the market where a lot of storage solutions out there will move from traditional storage, traditional kind of setups to a software-defined setup. So then, as I was talking about why it is specifically interesting to look at Compuverde, the first thing is the flexibility. So you are completely free to choose whatever kind of hardware you want to set it up on. You could choose to reuse your hardware that is lying around in your data center, as long as it confines with our best practices. It is completely scalable, so you don't have to make calculations and predict how much you might be using in the next 5 years or so. So you can start off with whatever you have at the moment, and depending on how your data needs grow, you can grow along with it. And the scalability comes with the overall solution comes with a lower TCO, because it makes it very easy for you to reuse whatever components you have, and also customize the solution based on your specific use case. And finally, it's a unified storage solution, meaning you're future-proof. You get to have a file system, you get an object store, and you also get a block storage. So it's an all-in-one kind of solution. And finally, at Compuverde, we really look towards reducing the complexity of your system. The whole solution is very user-friendly. The installation is basically 15 minutes for you to start installing a node to getting up your file system and have your customers putting their data on your file system. So it's very fast to get it up. It's very easy to set it up and also manage. And we really concentrate on the usability and the reduced complexity of the system. And then, because you've got the choice of making your own kind of setups and customizing it based on your needs, you could put Compuverde in a lot of different use cases. So you could use it in a VDI environment, you could use it to host databases or any kinds of enterprise applications. You could set up private and public clouds with it. We also have a hybrid cloud setup, which allows you to communicate or share data between the private and public clouds you set up. Or you could also just have Compuverde as your backup or a DR environment as well. So in a nutshell, what that means is with Compuverde, we aim to reduce the complexity of your system and make it really simple, everything in one box kind of solution. So you move away from your legacy infrastructure, which is a lot of different silos, a lot of moving parts, which might be complex to manage and intercommunicate. So we take all that functionality, put it in one box, and make it really simple for you. So you've got all the functionality that you're used to or you would like in your setup, and then that comes along with the reduced complexity and the lower cost as well. So going a little bit into what kinds of installations you can do with Compuverde, we have 4 primary kinds that we talk about. The first one is what we call the scale-out storage. This is our simplest setup, as we say, because you are directly installing the software on bare metal hardware. So take your hardware, put our ISO on top. You do this for at least 4 servers, which is our minimum setup to go into production. Then you use our GUI and configure your 4 nodes to be a part of a single storage cluster. And once you've done this, the 4 nodes will start to behave intelligently and they will start talking to each other. They are aware of their neighboring nodes, they're aware of the health of their neighboring nodes, and they behave coherently. You will have a single namespace over all your 4 nodes, meaning whatever you read and write to, let's say, the first node in your cluster is exactly what all the others see. So the whole solution is synchronous as well. Going a little bit into the architecture, you could divide the solution into 3 virtual layers. So at the bottom, we've got the storage layer, which is made up of our object store. This object store is what gives us our flexibility and also our ability to scale without any limits. Then on top of the object store, we've got our virtual file system. So we convert all the objects into a file structure that your customer or you as an end user will interact with. Then on top of the file system, we've got our own protocol layer where we are providing you support for all the major protocols in the market like SMB, NFS, iSCSI, OpenStack Swift. We also have a Cinder plugin and Amazon S3 as well. So you could choose to use any of these protocols to access your storage below. So this is the simplest of setup where you're directly installing on your hardware. And then you could also choose, if you have a virtualized environment, to go into a hyperconverged setup where you're kind of combining both storage and compute together in one package. So what this means is you would first need to install whatever hypervisor you like on your hardware. We support ESXi, Hyper-V, KVM, and Xen. So you put whatever hypervisor you like on your hardware, spin up one virtual machine or your first virtual machine, and then install Compuverde on this VM. You do this for each of your servers. So when you've got 4 servers, each installed with one hypervisor and one Compuverde VM, you will then configure all your Compuverde VMs to form the virtual file system. So as you can see here, with 3 nodes, you see 3 VMs that have Compuverde on inside of it. And these Compuverde VMs are the ones that will offer the virtual file system to the guest applications or the guest VMs. Also with the hyperconverged mode, we are directly talking to the disks through pass-through or RDM. So that makes it that we have complete control of your storage disks underneath. Also with the hyperconverged, you get the same features that you get with the scale out, meaning you still have the support for the protocols, the file system services, the block and the object store services. You still have the ability to scale. Also, all your nodes are talking to each other and they're synchronous, meaning whatever data you store on server number 1 is available to share with all the other servers or all the other VMs that are in your cluster. So both the scale out and the hyperconverged modes we talked about are single data center scenarios. So if you have just one cluster or one data center. But then if we were going into scenarios where you have multiple data centers, or more specifically 2, that we want to mirror data across, then we come into the metro cluster. So you can set up both the hyperconverged or the scale out in a metro. So what do you mean by a metro is that you will have 2 data centers, 2 different locations, and these 2 data centers are synchronously mirroring data across each other. Because they have to mirror data, you have a few constraints on this kind of a setup. So you will need to have a low latency uplink between these 2 locations, a connection whose latency is less than 5 milliseconds. And also these 2 locations are supposed to be on the same LAN. Once that is done, the positives of the metro is that you're able to lose one complete data center and still be up and running. So if one of your location has gone down for some reason, you can immediately switch over all your customers to the other location and you're up and running within no time. So talking about scenarios where you still have multiple locations, but you don't have the ability to have a sub 5 millisecond latency, we go into the hybrid cloud setup. We have version 1 that is out right now. And what you do with version 1 is a disaster recovery scenario. So what that means is you could have one primary data center sending out snapshots to up to 16 different locations. They can cross-communicate with each other. And if your primary location has gone down for some reason, you could restore data from your snapshots and any of these other locations that you've mapped it to, and start moving your customers to those locations, and they can start using data from there. We will soon be coming out with a more advanced version called version 2.0 of hybrid cloud. And then on, we aim to actually allow real-time live sharing of data between different data centers in a very flexible manner, where you can select what data, what folders you want to share between data centers, and you can select the different rights and restrictions that users will have on that kind of data. So those were the 4 different kinds of setups you could make with Compuverde, or you could install in your data center. So let's go and talk a little bit about the different features that you get with Compuverde. The first up is scalability. So as I said, it's very easy to scale, and you could start off with whatever amount of storage you currently have, and you can grow from there on. So you can grow in terms of storage in two ways. One is what we call scaling up, where you're adding additional disks to your enclosures. So if you've got empty slots in your enclosures, you're adding more disks. And the other one is what we call scale out, where you're adding additional nodes. So when you add additional nodes, you could do this one node at a time. So you don't have to have, we are not having constraints on having a particular amount of nodes by which you scale. So basically you scale one node at a time, and also the architecture is made very simple in Compuverde in terms of you don't have any special nodes. So no special metadata servers, no special compute nodes or compute servers. Because of this, when you add or when you scale out or when you add nodes to your system, you linearly increase your performance along with the capacity. Because each node is exactly doing the same thing. When there are more nodes in the system, there are more nodes that work towards the same goal. So you have an increased performance along with larger capacity as well. Then talking a little bit about what kind of hardware you would need to use. So basically you're free to use any x86 servers you've got. The only thing that you need to keep in mind is that each server would need to have one storage disk, one cache disk, which is preferably an SSD, or if you're looking at a high performance scenarios, you could also do PCIe cards. And then you would need to have one boot disk as well in your server. So one storage, one cache, one boot disk in each server, and then of course a network connecting all your servers in the cluster. So down here you could see a couple of minimum and recommended system requirements. All this information is also up on our website. So when you make a download, you would get these checklists just so that you can tick off and make sure that you follow our best practices that we recommend. Then we would like to talk a little bit about performance, because it is important that your performance needs are met. So just to give you a benchmark or a comparison point, what we did is we put together hardware that was quite similar to Isilon S210, which is their flagship model. And Isilon have done a couple of public tests with a tool called Spec SFS 2008. So what Spec SFS is doing is it is emulating 10,000 users doing random things on your storage cluster. And it's a 12-hour run, and it shows how much file IOPS your storage was able to provide. So they had made this test and they have a public result up on their website. So we picked up their result. We made a hardware setup quite similar to theirs, but we were using commodity hardware instead. Doing the same test, running the same test run, we were able to achieve 540,000 file IOPS, while based on EMC's result, they show a performance of 360,000 IOPS. So this is just to give you an idea, saying that in terms of performance, we are quite well performing. And if you really like to go even bigger performance numbers, you could also do an all-flash setup where you're using NVMEs for cache and then SSDs for storage. Then talking a little bit about our protocols. So we are using our own versions of protocols, meaning that we've developed them from scratch. So that means that we don't use Samba. We have developed it from scratch, meaning we've got really good control over the protocol, and also the protocols are really well integrated with the rest of the solution. So here are some numbers that are just giving you an idea of how compliant our versions of SMB, NFS, and iSCSI are when compared to the other versions that are out there in the market, like Samba, or even compared to Windows Server as well. After talking a little bit about protocols, we talk a little bit about the reliability of the system, which is really important. So when it comes to high availability, the good things to mention are that the whole cluster is active-active. So if you've got 4 nodes in your system, you can use all 4 to access the storage underneath. As I mentioned, all nodes are synchronous. So as soon as you write something to node 1, it's immediately visible to all the other nodes in your system. And then we've got another feature called virtual IP, which ensures that even when you have something that is going wrong with your cluster, like a broken disk or a broken node, your cluster will always seem up and running and available to your end users. So how that's done is, let's say, as you can see in the picture below, let's say that a user is accessing node number 1 and making some reads and writes towards it. And for some reason, this node is broken down. What virtual IP will do is it will move over the access IP of this node to another healthy node in the cluster. It is randomly choose based on the health of the other nodes and how much stress they're under. And whatever the user operations were directed to node 1 earlier will in the background be migrated to the new node. So the end user never notices any downtime. He never sees that a node is broken down, and he always has the storage available for him. So this is also interesting because when you want to make maintenance on your cluster, when you want to maybe do firmware upgrades, you don't need to take your cluster down for a maintenance period. You can have it up and running and make upgrades on your cluster at the same time. Then talking a little bit about the reliability of the system. The whole cluster is self-healing. So as I mentioned that all the nodes in the cluster are aware of its surroundings, they're aware of the other nodes in the cluster. They're also able to detect when a disk is broken or when a node is lost, and they're also able to detect what data was lost along with that node. And whenever something is broken, they will recreate that data inside the space that is left in the cluster. So they will self-heal pretty quick. And also added fact that because of the architecture, keeping it really simple, really flat, and because we don't have special metadata servers as such, when you break something, self-healing is a really fast process. It happens, and also it doesn't consume a lot of resources in terms of CPU or bandwidth as well. Then to have a little bit more reliability, we also support snapshots. So you can make manual snapshots using a CLI, or you could make automatic snapshots that you could configure in the Compuverde GUI. And then we have something called erasure coding, which basically determines how many nodes you can lose in your server and be up and running. So we primarily have two kinds of erasure codes, a +1 kind and a +2, which basically means that with the +1 kind, you're able to lose one complete server, be up and running like normal, and with the +2 kind, you're able to lose 2. You've got a couple of choices in both the +1 and +2 kinds, and depending on the number of nodes you have in your system, you can make your choice. And depending on the choice, you get different kinds of redundancies and different storage efficiencies as well. Finally, I just would like to talk about a little bit about a few more features that we have that are a good mention, I think. First one is that we're fully flash compliant. Then we also support multi-tenancy, which means you can have multiple file systems on the same storage cluster. Each of this file system will be independent from one another. So you could have, let's say, different departments of your company that are running its storage towards the same storage cluster, and each department will be unique. They will not be able to see data from one another, so they cannot look into the other cluster, and they would feel like they own the storage cluster for themselves. So that's on the storage end, and you can combine that with VLANs on the network end and also put each file system on a separate virtual LAN as well. Then we support quotas, which is limiting how big a folder or a file system can get. Then you can make policies where you say, when you want to delete data, how long you want to have retention of the data for, or maybe you want to change the erasure coding later on. So you can make such file policies with, within the GUI. And then if we're talking really large clusters, you could also have tiering, which means large clusters, you might want to have some special nodes, some slower nodes, and you can then, when you have such different kinds of nodes, you can put them in different logical tiers. And you can then also have file policies combined with tiers and say, okay, I want to first hit my fastest tier when I'm reading or writing, and then move my data towards these lower tiers later on. We also support encryption. So that's for data on rest. And we are doing AES with the 256-bit key. And then finally, in terms of networks, the one thing that I missed out is bonding. So for redundancy on the networking end, you could bond different interfaces as well. So that was a quick overview of what Compuverde does in terms of storage. I'm hopeful that you might see it interesting in your use case. And one thing that I would like to mention before I hand over is that we've got a data center down here in Karlskrona, where we are located, that we are primarily using for our own testing. But you as a customer or you as a partner, if you want to try out Compuverde, you could always make a free download from our website and try it out on your end. But in case you don't have the required hardware yet, you could choose to get in contact with us and we can arrange for a virtual environment for you down in our data center where you can log in and test the features of Compuverde and just get a feel for it. So that's it from my end. Thank you for your time, and I pass it over to Ollie.
Thanks, Indusha.
Thank you, Sindusha. Just one thing before we pass it to Ollie. I just want to make sure that everyone knows that they can type questions in the question bar, and we will try to answer as we go along. If we don't get to it within the presentation, we will try to email you with the responses to your questions. So I wanted to mention that before we proceeded. So please, Ollie, go ahead now.
Thank you. Just share the screen there. So thanks for the introduction, and thanks, Indusha, for a great presentation there. What I'll be doing today is I'll be talking through the Big Switch solution and our approach to software-defined networking within the data center. So just to give a bit of background, as I'm sure a lot of you are aware, a lot of companies now are moving towards a software-defined data center simply because there's more usage of cloud-native applications, and people want to roll those applications out much faster. And cost optimization is a very big priority for a lot of organizations now. So the incumbent network hardware vendors that have been traditionally used within the data center are proving to be very expensive and a real barrier towards that modernization. So that software-defined data center gives you the ability to automate many of the functions of rolling out applications, as well as looking at the data center from a logical perspective and having this concept of scale out. And scale out, for those of you that are not aware of that particular phrase, scale out basically means that rather than buying larger and larger switching infrastructure, what we're proposing with the software-defined data center is that you scale out, i.e. add in more of that commodity bare metal hardware and increase the size of your switching capacity incrementally as you need it. So rather than a big bang upgrade, we're talking about adding in these components as time goes by. So to look at the way networking has been done traditionally that's been a box by box operation. And what I mean by that is you would have a series of layer 3 aggregation devices and layer 2 access devices, and those would be interconnected to one another using a myriad of different protocols. Now that box by box operation means that each of those individual devices has to be accessed individually and configured individually as a standalone device. So when you make a change to any one of those devices, this is where the brittle and opaque part comes in, is that you've got to make sure that you make that change on other devices, because that may affect the overall performance and availability of that particular application. So let's say I add in a new VLAN, I've got to make sure that I add in that VLAN into other layer 2 access devices. And maybe I've got to add in routing as well. And all of that's done via typically a 1990s CLI, which, you know, there's nothing wrong with that, but it does slow things down in terms of rolling out these applications. And that's particularly acute when you look at things like virtualization and you look at containers, where you might want to spin up a VM or deploy containers very quickly and make those changes very fast, but that box by box operation really slows it down. So that's becoming a real barrier for us within the data center modernization. Now, just to give you an analogy, if you look at a car will have an engine inside it. That engine is a very complex piece of machinery, and you don't actually have all of the engine details exposed to the driver. You know, what the car industry has done is they've kept a lot of that complexity hidden from the user. So looking at the way in which the car industry has approached that, they've simplified the operation of the automobile. So what they've done there is they've said, well, what is the intention of the driver? The driver wants to steer, wants to accelerate, wants to brake, wants to navigate. And, you know, that's taken a step further when you think about things like cruise control and now the self-driving car. So looking at the way in which people have traditionally done that network with the complex and brittle and opaque feature-driven and box-driven network within the data center, Big Switch are moving towards more of an intention-based and software-driven and logical approach to the network. So this allows us to very quickly add in additional leaf and spine switches into the fabric, which can be done very fast by simply plugging that into the fabric and registering it with a controller. That actual provisioning of the fabric, also known as zero-touch networking, is where each element within the fabric can automatically bring up its links, do its load balancing, link aggregation groups, and so forth automatically within the fabric. And then we can automate things like adding in additional servers, adding in VMs and containers by API interaction between the controller and an orchestration tool such as VMware vCenter, for example, or into OpenStack Neutron, for example. We can also very quickly and easily audit the app connectivity between nodes that are attached to the cluster, attached to the fabric, without actually having to be on that device itself. So we can do things like simulate routing. We can also test routing by inserting packets into the fabric to make sure that applications can communicate with each other, not only from a layer 2 perspective, but also from layer 3 and layer 4. So we can actually check those ports. So by enforcing those routes as ACLs, which provides us with a certain amount of security and segmentation, we can also audit that very quickly and easily. And that knowledge-based and self-operating fabric gives us an intelligent, predictive, and cloud-native approach. So that means that, you know, I can make changes within my virtual environment or within my container environment, and those are automatically provisioned for me by means of the API and the software-defined networking controller, and they're provisioned automatically within the fabric. So once it's set up, it gives me a lot of acceleration in terms of deploying those applications and getting the network up and running fast. So Big Switch as a company, we're the next generation data center networking company, and our company mission is split into two halves. There's the next generation data center switching and the next generation data center security and monitoring. Now, those actually translate into two product lines: the Big Cloud Fabric, which is our switching infrastructure, which is provided by a software-defined networking controller, and that allows you to run a VMware software-defined data center, OpenStack, and containers simultaneously within the same fabric. From the next generation DC security and monitoring side, we have the Big Monitoring Fabric, and that's there to provide access to traffic running across the network to attach tools. So that gives us our pervasive visibility right across the data center, meaning that tools can share traffic collected from the network, but they can also be load balanced and shared amongst several tools, meaning that you can actually scale out those tools as well. The DMZ security gives you the ability to load balance inline tools, such as intrusion prevention systems, web application firewalls, and inline web proxies, for example. And we also have options for monitoring inside that private cloud as well. And that's really inspired by work done at Google, Facebook, and Microsoft, which is using that software-defined controller hardware, software, and utilizing open networking hardware, thereby reducing the cost of the actual hardware which is being deployed. And that gives us our scale-out fabric architecture. So we can add in additional switches as our capacity needs grow over time. So why use this hyperscale inspired networking or scale-out architecture? Well, one of the big drivers here is the total cost of ownership can be up to 50% less. So what we've done at Big Switch is we've taken that traditional model of support, software, and hardware and collapsed the support and the software price into a single line item. And that is reducing the cost, but also the open networking hardware significantly reduces the cost over a 3-year capital expenditure. But the real savings are within the operational expenditure. So you can do configuration upgrades very, very fast with the Big Cloud Fabric. That means you can get those applications out faster, and it also means troubleshooting and resolving those issues is much faster because you don't necessarily have to start logging onto machines to see if they can communicate and start doing dumps and so forth. And you know, if anyone would be interested in seeing more of that in another session, I'd be happy to take that offline later on. And that's actually something which is covered by the ACG research paper, which is available on our website, which you might be interested to read to learn more about these savings, both as capital expenditure and also for operational expenditure. So to look at the way in which we translate that traditional chassis pair, which is typically end of row in a data center, you would have a chassis which essentially comprises of 3 main components: a supervisor card, which orchestrates the configuration of the line cards on the device, and a fabric backplane, which connects the line cards to the supervisor. The line cards are actually doing the switching, and how that translates across is the supervisor is replaced by the SDN controller, which provides a hierarchical control plane across the entire fabric. That fabric backplane is replaced by spine switches, which interconnect the leaf switches, which are the replacement for the line card, together with a completely non-blocking and load balanced fabric infrastructure. So we don't use spanning tree here, where we're using equal cost multipath routing to interconnect the leaf switches with the spine switches, meaning that the maximum amount of bandwidth is always available. And when deployed in a redundant fashion like this, it means that one of these individual open networking hardware switches can actually fail and the fabric is still maintained and operational. Now those leaf switches can connect into a compute load, be that a physical, virtual, or container workload. We also have options to extend the reach of the Cloud Fabric controller into OpenStack environments and provide management of virtualized switches. The leaf switches also will connect into the greater network, so that would be any routers or firewalls connected on the network, which means that really this is just one logical switch, hence the name Big Switch. So it means that all of these different devices are configured as one single thing through a single pane of glass, meaning that you can make configuration changes and roll these things out much faster. And with that automation piece, it means that I can make changes within, let's say, a VMware environment, where I can create a new VLAN or dport group within VMware, and that's automatically provisioned in the physical underlay, which is controlled by the SDN controller with Big Cloud Fabric. So to look at some specific use cases for Big Cloud Fabric, we have the VMware integration, which includes NSX. So you can actually terminate VXLAN into the big cloud fabric. But we also have the integration with OpenStack and container orchestration tools such as Kubernetes and Red Hat OpenShift. And that takes it a step further inside OpenStack. Because it's open source, we're able to write our own OpenStack switch, which can be actually controlled by the SDN controller itself. With Big Monitoring Fabric, we have the pervasive visibility and security, which means you can plug in those out-of-band tools such as intrusion detection systems, network recorders, and application performance management tools to gain traffic from the network and share them amongst those tools, making more efficient use of those tools and potentially reducing the number of those tools. With DMZ and extranet security, we're able to do load balancing for inline tools such as IPS and web application firewalls, which traditionally have been very difficult to load balance and very difficult to deploy in asynchronously routed environments. And all of the traffic going through that DMZ and extranet security can again be shared with those out-of-band tools so that you can actually see passively that traffic as well. So it's all about making the best use of those passive tools deployed on your network. So in terms of mainstream customer adoption, we have a number of customers which use our products globally. In the region, I would say Dubai municipality is probably the most relevant. But what we found is a lot of customers will come to Big Switch, make an initial purchase, and then come back and repeat that purchase. So that's really where people are actually scaling out and potentially replacing other more legacy parts of their infrastructure and increasing the size of their Big Switch deployment. So to have a focus on Big Cloud Fabric, which is really the side of the portfolio that I'm going to spend the most amount of time on in the presentation today, we have those deployment use cases. So we have talked about VMware, we have talked about OpenStack, and we've also mentioned containers. And just to touch on containers one more time, containers is a particularly interesting proposition because of the volatility of your container deployment. And by that, I mean you might have a series of applications which are containerized within your environment, and they may change very suddenly over time, depending on workload. And having an automation piece between those containers being deployed within your container environment and the physical underlay is a major advantage when using that type of technology. And lastly, the data center fabric, we can actually connect into any workload. So it doesn't have to specifically be a VMware, OpenStack, or container workload. You could use a traditional database server, email server, Hadoop cluster, and you can also use other hypervisors within this as well. So this gives you a lot of simplicity and visibility, and gives you the ability to look at your network from a logical rather than from a physical perspective. So how that all plugs together is the Big Cloud Fabric will communicate via API to those orchestration tools such as OpenStack, VMware, and Kubernetes. And that's a single programming interface which allows those third-party orchestration tools to communicate with the controller to automatically provision additional VLANs into the physical underlay itself. Now, the Fabric controller will actually provide the operating system to any of the commodity hardware. So I've got a couple of vendors here which offer the open networking hardware. There are a few available on our hardware compatibility list, but essentially how this works is the open networking hardware switch would be turned on the network, and once registered with the controller, would effectively boot its operating system from the controller itself. So in terms of doing things like upgrades, that makes that very simple because it's just a question of upgrading the Fabric controller cluster and then rebooting the switches. And you can do that incrementally, thereby avoiding any disruption. We also have a little bit deeper, we have SwitchLite VX, which is the software version of the switch, which sits within those OpenStack environments. And you don't necessarily have to use that. Some people choose not to, but it's there as an option. And all of the routing within the cloud fabric, as well as all of the switching, is completely controlled by the big cloud fabric controller. So those interconnections between those leaf switches at the bottom there, which actually connect to the physical servers and virtual workloads, don't have to be configured for their connectivity into the spine switches at the top there. So if you're deploying this in an existing data center, what I'd like to make very clear is we're not proposing that on day one you have to remove all of your legacy hardware and have to replace that with the big cloud fabric. You can actually do that incrementally over time. And if you think about how a data center is arranged, it's a set of layer 2 devices connected to layer 3 devices connected to the greater wide area network or internet. So you can actually run this quite happily alongside your legacy box by box environment and replace it as time goes by. And you can extend the layer 2 boundaries between these big cloud fabrics inside your data center by either using a layer 2 connection between them, or alternatively you can use VXLAN if you want to extend that layer 2 boundary across a layer 3 network. So for example, I might have a VMware deployment in which I need layer 2 access across two of these separate big cloud fabric instances. I can extend that using either VXLAN or, as I say, a layer 2 connection. VXLAN is obviously more appropriate for remote sites such as DC2 in the top right hand corner of this slide. And to look at that from physical versus logical topology, we have that in this instance we're looking at VXLAN, so we're extending that layer 2 boundary between DC1 and DC2, and that's how that looks physically. But in terms of how that looks logically, we can have multiple tenants. So in this example, we have tenant A and tenant B, which are actually extended across those two separate big cloud fabric instances by means of a VXLAN tunnel. So that means that tenant A can quite happily communicate with all the other tenants in tenant A, no problem. Likewise for tenant B. And this doesn't, please don't think that this means that those two tenants are completely segregated from each other, because again, we can, within the software, provide routes and ACLs between those tenants so that they can communicate with each other if required. But this is this segmentation is particularly attractive for people who are providing services to their customers, for example. So that multi-orchestration, please also don't think that you must only run VMware within a big cloud fabric, or you must only run OpenStack. You can actually run multiple instances of different, what we call virtual pods, within inside the big cloud fabric controller. And those are essentially tenants with underneath what we call segments, which is essentially VLANs, and you can segregate those completely from one another. So, if you're a VMware house and you're looking at testing OpenStack, for example, you can run these two things side by side and completely isolate them from one another. And there's a testimonial there from the CEO at U2 Cloud, which is a service provider for cloud services, and we really help them in segregating that in between their different customers. So really, just to summarize the big cloud fabric, this gives you a lot of flexibility. It means that you can focus on the intention of your network, which is really providing those apps and the connectivity to the network. But we also have taken a very much a programmatical approach by having an API first coding principle applied to the fabric, so that any feature within the fabric, from configuration or querying statistics, can be done through the API. We also provide analytics, so you can get an idea about who's talking to who, what ports, protocols, and so on are being used across the fabric without buying any additional tools in. And so putting those additional extra servers or VMs and containers and auditing that application connectivity is all very much simplified by our single pane of glass management with Big Cloud Fabric. And that really brings me to the end of the presentation. Thank you very much.
Thank you very much, Ollie. That was very good. Thank you all for attending the session. I hope it was beneficial. Hopefully you've seen what these software-defined solutions from Compuverde in terms of storage, and from Big Switch in terms of networking can do. In terms of making the environment more agile, scalable, really easy to control. And also adding values like lowering the vendor lock-in and giving huge economic savings. Please feel free to explore this further. You can always email us at info@distilogix.com. We'd be happy to arrange sessions to learn more. If you want to see a demo, if you want to arrange a POC, please do let us know. So thank you everyone for your time, and we hope to see you on a future webinar.